how to see this pattern, the flower of life. What we're ultimately talking about in this video is intrinsic geometry of the brain and how to see into the central nervous system. And we'll use this shape as an example because the flower of life comes from the central nervous system. The New Age people might say a lot about the flower of life and what it means or something like that, which I don't necessarily care for or agree with. If it is a pattern found throughout the universe, it's probably just a efficient organizing principle, kind of like labyrinths or layers and ridges and folds. It's a way to condense information in a small space because you can just overlap these circles. That being said, it is cool to see, and it's a structure in the central nervous system. The way you can see it is you lay down under the sun with your eyes closed. So you want to face the sun. It may take 10 to 20 minutes, but then you'll sit up at some point when you start to feel maybe uncomfortable. You sit up and look at a monochromatic background, so like the blue sky or maybe a grass or some kind of wall. And sort of superimposed or embossed in your visual field will be this mosaic grid pattern, the flower of life. So let's explain why you would see this and what it is we're actually seeing. So quickly run down how vision works. You have light entering the eyes, and then they're hitting the back of the eye where you have your retina. This is where you have your photoreceptors, and through a process called transduction is going to convert that light into electrical signals, into action potentials. Your body does this for any sort of information it gets, whether it's hearing, taste, touch, or smell. You're going to transduce that information into electrical signals because that's how the brain works. The electrical signals will be sent through the optic chiasm, and the left eye goes to the right hemisphere and the right eye goes to the left hemisphere. Then it goes down through the LGN, the lateral geniculate nucleus in the thalamus, and to the primary visual cortex. From the visual cortex, the information could be sent to the parietal lobe or the temporal lobe, where it's going to get memory information, depth, awareness, where you've seen it before, kind of understanding what you're looking at. You need action potentials in your visual cortex in order to see, but they do not have to only come from the optic nerve. In fact, electrical signals can come from any part of the brain that connects to the visual cortex or goes through a circuit that goes to the visual cortex and you can see. So things like dreams and hallucinations and vivid imagination, those are electrical signals coming from different regions of the brain and going straight into the visual cortex where it appears like you're seeing it in your eye. So when we're seeing this flower of life phosphene, it's electrical signals coming from a different region of the brain. The reason why we need a powerful light, though, is because you still need that transduction. You need those light particles to be converted to electrical signals in order to sort of light up your nervous system. Now, when it comes to this flower of life phosphene, I suspect it's actually a structure in the visual cortex. So you're actually seeing the visual cortex. One of the reasons I suspect that is because the LGN itself and a lot of aspects of the visual cortex are like half circles. So when you put two half circles together from the right and left hemisphere, you would create a ring. If you lay back down and continue to build up that pressure, you're going to cause hyperexcitability of these electrical signals. At this point, you'll get these electrical flashes. They look like projections of light that just come and go, and it seemingly is chaotic. But if you're able to focus and keep track of them, you'll see that they're actually in a grid. And they're going to be staying within this flower of life grid. They're going to be using that pattern because that's the grid of one part of the visual cortex, or whatever other part of the brain it could be. But the point is that these electrical signals, they're going along the path that you happen to have seen sort of stained or embossed into your visual field. This is a little different than seeing floaters, because with floaters, you're actually seeing objects in the eyeball itself. In this case, we're seeing these flashes of light and these phosphenes in the visual cortex, meaning it's electrical signals in some part of the brain being sent or relayed to the visual cortex. Even though it looks like you're seeing it in the world or seeing it in your eye, it's actually taking place in your visual cortex, but that's just how images are interpreted in the brain, right? You look at anything, you're looking at this phone, it's taking place in the visual cortex. This is also confirmed by keeping your eyes closed. You'll still see some of these flashes. The blue field just helps with the contrast, helps make it more noticeable. The process of sitting up after letting the blood settle helps because that perfusion of blood is going to hyperexcite the nerves, which gives you the flashes. The same thing happens when you are sitting too long and you stand up and you get that head rush and you may feel lightheaded and you'll get sudden flashes of light. So it's the same thing happening as this, but when we're focused, we're activating or using a certain region of the brain. If you're doing this again and you're laying in the sun and you direct your conscious attention to maybe a memory or a skill or a problem, you're going to send that blood to a different region, and then when you get up, it's going to perfuse out, and then you'll have a different structure, you'll have a different grid phosphene. And this comes back to the main point, which is that mental activity is not only a function of the brain's structures and its connections, but it's also a consequence of its intrinsic geometry. In fact, mental activity is usually described very geometrically, has a very dimensional or spatial component. You'll say you're thinking inside the box or outside the box. Or if you're losing your grip on reality, you might say you're spiraling. Or if someone always goes back to the same point, you'll say that it's very circular thinking. We also have the idea of compartmentalization, which is storing something in a specific room in the brain. You also have this idea of going down the rabbit hole, which is taking information up in the higher thinking region of the brain and trying to forge a path that connects it to other things, right? You're finding information and you're going down this path of thinking. The same way we say a train of thought, right? It's a direction and a circuit of mental activity. And still someone may be narrow-minded or have tunnel vision when they're only thinking of one thing. Even though we use these imaginative terms, mental activity is a consequence of that intrinsic geometry. As a metaphor, if you take blueprints of two different houses, you'll see that they may have all the same rooms, but the rooms may be slightly different sizes or connected at different hallways or just in different sorts of arrangements. That's what the brain is like. Your experience of the house is determined by its geometric architecture. So it's not only what you do with the room and how you decorate or use it, but the actual space of the room determines what you're able to do with it. Some of these shapes are going to be fairly universal, as in they're foundational to how our brains have just evolved or developed, like the flower of life, for example. But there's an endless amount of geometric structures, whether symmetrical or asymmetrical, because the brain can connect in any way that it wants. And the more efficient you get at something, the more skilled or knowledgeable at something, the less brain activity you need. This is when it becomes second nature, is what we say. The action potentials are so well connected within that intrinsic geometry that has been forged through repetition and learning and skill that the action becomes second nature, it becomes almost an instinct. In my opinion, what people believe is less interesting than how they believe it, because the how of what someone believes is a reflection of their intrinsic geometry, right? The path, the logic system they use to reach a conclusion. And on a side note, that's also why logic isn't a universal thing that all humans can use to the same degree, unless we all had the exact same intrinsic geometry, which is also how you would get something that resembles a hive mind. When people are arguing or debating and someone says, oh, you're not being logical, they're just using a logic circuit. Their intrinsic geometry is just laid out a little different than yours. But because of neuroplasticity, you have this unlimited amount of connecting things in ways you can connect things, kind of like using mnemonic devices. Anyone can use the mnemonic devices that they associate with. It doesn't have to make sense to anyone else. But in order to see these structures inside the central nervous system, you need a strong amount of light, and you need to have a region of the brain activated. You need to have that blood flow, and then when you move that blood, it's going to hyperexcite the nerves, and you're going to have this superimposed relay of those electrical signals in your visual field. This is where most of your sacred and ancient symbols are coming from, but you could also have things like spider webs and spirals and fractals and any number of different shapes and geometric patterns, because it's all that intrinsic geometry. Thanks for watching.